Hi everybody and welcome back. Today we're going to wrap up our discussion of Pandas and all the things you can do in Pandas to manipulate data, get it ready for analysis. So let's start by comparing just head-to-head Pandas and SQL, because both of these options can be used to select and rename columns, filter and sort rows, join tables, aggregate data. SQL can do this. Pandas can do this. So we've been through all of SQL in Module 7. In Modules 8 and 9, we've been through Pandas. The question is, should we be using SQL or Pandas to perform all of these data manipulation steps? Well, SQL is sometimes referred to as a server-side data manipulation tool. And that's because databases are often stored on remote servers, and SQL queries can be processed on the server instead of on a local machine. So sometimes you'll hear this debate phrased as server-side versus client-side. Client-side means local, right? In this case, Python is our local installation. So server-side for SQL, Pandas is client-side. So the question of SQL versus Pandas, that gets debated quite a lot in data science. And the existing evidence does not overwhelmingly support one option or the other. We could think about, is SQL better than Pandas in terms of speed? And in some cases it is, in some cases it's not. It really varies depending on the quality of an internet connection to a server. It varies based on the configuration of a database. And so I think the most important thing is knowing both tools, because they will almost certainly both become part of your workflow. Now, there are some specific points to consider when deciding whether to use SQL or Pandas. And the first point is, if the data don't come from a database, the question might be moot. It is going to be a big pain in the neck to put data into a database just so that you can use SQL. Pandas is easier in that case, because if you are just downloading, say, from a CSV, you can start doing the data manipulation right away with Pandas, and you don't need to create a database just to use SQL. Second, if we're thinking about differences in speed, I don't think it's worth thinking about until we're working with a very, very big amount of data. In those cases, we're almost always going to be working with data that's stored on a remote server, right? Because very few of us have local hard drives that can fit a huge amount of data. So in that case, again, the question might be moot, because we're going to be using SQL anyway to pull a selection of data. We might use SQL to pull some data from the database and then use Pandas to work with it locally. There have been comments that I've seen looking around for opinions on this that said this is a good way to get around angry database managers. So you could think about that. Point 3 to consider, Pandas simply has more functionality and flexibility for doing data manipulation than SQL. Now, SQL has extensions in specific DBMSs that can work, that can do more things, but it can be awkward. And generally, there are some things that just don't work that great in SQL, and Pandas just does way better, including reshaping that we'll talk about in this video, working with strings and time and date features. Now, another point is that when you go and start working, your workplace might require you to use one tool or the other, simply because that is part of the set of tools that your workplace uses. So if you're working as part of a team that uses Python, that uses that does data science in Python, you will be using Pandas all the time. SQL is very readable and usable for people who do not use Python. SQL is very universal, but it still works with databases no matter what platform we use. So sometimes you don't even get the choice. Sometimes you'll be told what to use. Another reason why you need to know them both. But other than that, I think if you have the choice between Pandas or SQL, I think it's important just choose the one that you yourself feel most comfortable using. Remember, and we talked about this at the very beginning of the course, remember that this data manipulation can take up 80% of our time, right? So anything you can do to reduce the time you spend on data manipulation is a good thing. And if you can move more quickly in Pandas and SQL or vice versa, by all means, use the tool that you feel more comfortable with if you have the freedom to do so. So like I said, we're going to practice both. Okay, so that aside, there's a few more techniques in Pandas that we need to discuss. The first is reshaping data frames. So for most applications, what we need is a data frame in which our observations or cases or records, whatever you'd like to call them, are in the rows, and the features are in the columns. Now, if we have time points like years or months or days, those should go in the rows, right? Like we should have a different row for every point in time, not in the columns. Okay? Now, this is an example data set that is quite messy from the standpoint of reshaping data. I got this data from the Bureau of Economic Affairs. It's just freely available online. It has data on all 50 states and on years from 1997 through 2000. I have it cut off here at 2006, but it goes up to, I think, 2015. Anyway, this is economic data that I might want to use for an analysis, state by state. Now, it's got some problems. Take a look at component name, right here, and description right here. These two columns define our features. And it goes row by row, right? So one row is defined by the state and by the feature. So if we go down, we see like here's GDP for all industries, GDP just for private industries. If we go down further, we would get different features under component name. So currently the features are in the rows, not the columns. Also, take a look at the years. They're in the columns. They're not in the rows. We need them to be in the rows. So we're going to have to do a couple reshapes to get this data into a form that we can use. Okay? And so let's talk through how we do that. There are two kinds of reshapes. The first kind is a wide to long reshape. Wide to long. That means we're going to turn some of the columns in the data frame into rows. From wide, more columns, to long, more rows. Okay? And then there's long to wide, the opposite. We're going to turn some of the rows into columns, right? So we have a wide to long and a long to wide reshape. A wide to long reshape is also called melting a data shape, and a long to wide is also called pivoting. Okay? Now there are two functions in Pandas that we're going to use. Now there are a few other functions, but these are two very simple, reliable ones, and this will be our focus today. So to do melting, a wide to long reshape, we're going to use pd.melt. And to do a long to wide reshape for pivoting, we're going to use the pivot table method. Now, reshaping can be very tricky. And a lot of people, especially when they're just getting started, fall into the trick of just trying out, what happens if I put some columns here, some columns there, and just kind of guess and check until it looks the way you want it to look. I think we can save ourselves a lot of time by delving into the different arguments of the two functions and really understanding how those arguments work so that we can get it right the first time. Okay, let's talk about melting first. So the PD melt function has three arguments: the data frame, the ID vars, and the value vars. The first parameter, the data frame, this is just the name of the data frame you want to melt. Okay? The second, the ID vars, these are the columns that we want to continue to exist as columns after the data frame is melted. Okay? So under ID vars, we're telling PD melt, leave these ones alone. Just leave them right where they are. Value vars, these are the columns that we want to store in the rows instead. Okay? Now, we're going to have to write all the names of those value vars, so sometimes there are just a lot of them, and we could use a shortcut like a comprehension loop to write all those names. And I'll show you an example of that So we have ID vars, the columns that we want to keep as columns, value vars, the columns that we want to move to the rows. Anything that's not specified under ID vars or value vars will be deleted in the melted data. Okay? And so here's an example. On the top here, this is my original data frame from the Bureau of Economic Activity that I showed on the previous slide. And now here is the PD melt. Okay, so there are three arguments. GSP clean, that's the name of this data frame that I'm working with. ID vars and value vars. For ID vars, these are the columns that are going to remain columns. So I wanted geo name, geo FIPS, region, component name, description. And you could see that these are columns both on the top data frame and on the bottom. Okay, the columns that remain columns. Value vars. So this is a comprehension loop, and here's what's going on with the comprehension loop. I'm looping from the number 1997 to the number 2015, and then for each of those, I'm converting that number into a string with str, and then putting it into a list. This is going to give me a list of 1997, 1998, 1999. In other words, it's going to capture all of these columns up here. And you can see what happens. It created two new columns, one called variable, right, which is going to contain the names, the previous column names, 97, 98, 99, and then the value. This is going to contain the data points for these columns. Okay, and so now you can see how we're getting closer to our goal of cleaning the data because we moved the years from the columns to the rows where they should be. Okay? Now we could rename these columns. We could rename variable into year, which we will. But we're not quite done yet because we still have component name and description, and these two things together define the features. We need to move the features to the columns. And for that, we're going to need to do pivoting, turning rows into columns. So, unlike melt, pivot table is a method, not its own function. So we start by writing df, which is the name of the data frame we want to reshape. So it's applied to the data frame we want to reshape. And in addition to that, there are three parameters inside that method. The first is index. Again, this is a list of the current columns that we want to remain as columns once we've reshaped. The second is columns. So this is going to be the name of the column that currently exists that contains the names of the new columns we are trying to create. Okay? So we have a column that contains the names. I know that that's confusing. You feel free to pause the video and just read this a couple times. I promise it'll make more sense during the example on the next slide. Okay? But one column contains the column names for the columns we're trying to create. That's what we write here. And then values. This column contains the data points for the columns we're trying to create. Okay? So these are the three parameters, and when we apply them, this, by the way, this is a note about if you have strings in those values columns, you have to specify ag function first. I don't want to get into it in this video, but please read the notebook for an explanation why. Anyway, this is what it looks like. Okay, so I'm pivoting on GSP clean. Okay. For index, state, FIPS, region, and year. Now, there's a difference here between what melt does and what pivot does. What pivot does, if I have more than one column specified under index, it's going to turn all but the last one into multi-indices, right? Actually, it's going to turn all of them into a multi-index. So this is all a index for the rows. They're not currently columns in the data frame. So Alabama, FIPS, region, and year, all of these define the row names. Now we're going to deal with that in just a second because in general, I don't like putting good data into row indices. when they should be in the data frame itself. So we'll talk about that in just a second. But previously I had created a column called feature, and you could see this, I skipped a couple steps, but you could see it in the notebook. I created a column called feature, which contained these things: gross domestic product, all industry total, gross domestic product, private, per capita real GDP by state, all industry total. So the column that used to exist named feature contained these strings as values. These were the names of the new columns that I'm creating. Value in the old data frame contained all these numbers, all these data points, which now populate these. Okay? And so now we have data that looks pretty close to what we need. We have years in the rows, and again, we'll deal with that on the next slide to get it out of the index, but we have years in the rows and features in the columns. That's exactly what we want. So the last bit is to get the data out of the indices and into the data frame. Then we just use the toRecords method and then pass it to PD data frame. And then now we have Alabama, Phipps region, year, and this is now clean. Now I can rename these columns here, and I will, but this is a working operational data frame. All we had to do was reshape a couple times.